So let's say the question says we are given a linked list. Now, that means we only need one root pointer to uniquely determine a linked list, just like trees. Yes. If you have this is not called root in linked list. This is called as head in linked list. So it's the head of the linked list. So if you just know the head, then you can just iterate and get to the next one, right? Yeah. Okay. So yeah, what I was saying is pointer manipulation is important. So let's take up a question which says you are given a linked list, and what you want to do is you need to swap pairs of nodes. So what I mean by that is, this is a pair, you will swap them. So 2, 1, then this is the next pair, you will swap them, 4, 3, and then 5 because it does not have a pair, then null. I just changed the data value. So what I can do is, so I can say node star current equal to head, while current does not reach the last. You'll take two things, current's data and current's next data, and swap them. So if your current next is available, then just swap current's data and current's next data, and then I'll move the pointer. So current goes to current's next. A simple idea. Take the first, swap it with the next, then move 2 steps ahead. Then take this, swap it with the next, move 2 steps ahead till you stop. But what is the problem here? If current next does not exist, in that case, we are not updating the pointer. Yes, but okay, you are saying it will go infinite. Yeah, so probably you can write here, right? If current is not null and current next is also not null, right? Good point, actually. Now it's fine. Now I think I don't even need this if, but still. Yeah. You can make it in other ways as well. Like you could have removed this, and in else you could have just written break. That if current next is not available, then you break. That can also work in a similar way. So it's not about like as such when to use something. It's just about what you want to do, right? Okay, cool. But problem with this is that we are changing the data. Question says you have to swap the nodes, that is without changing the data. Does the difference make sense? So what the question wants is that, let's say this memory, this memory, this memory, this memory, they are connected like this. You change the connections. You want your memory to start here, point here, something like this, right? So it just wants you to change the pointers and not the actual values of the nodes. Does that make sense? So right, so the memories should stay the same. It's not like you are just swapping the, like you are keeping the pointers intact and just swapping the data. That is not required. You need to actually swap the memory locations and make sure that this is first, this is second, this is third, this is fourth, something like that. So what I'll do is, I'll say I have a new linked list. I'll first insert 2 there, then insert 1, then insert 4, then insert 3. But again, that will create a new separate memory. I need to keep the memory intact. So that is also not a possible solution. If we get an updated list from 3 node, then we only need change first 2 pointers and return new head from 1 to null. Okay, that makes sense. Previous node could be used. Okay. Okay, so there are a few different patterns that I'll ask you to probably remember that are very common in case of linked list. So first pattern is, which we'll probably be using here, is to basically divide this list into 2 parts. So how are we going to do that? So if we look at it, what we need is 1, 3, 5. right? 1 3 5. It is exactly like this, 1 3 5. And 2 4 is also exactly like this, 2 4. It's just that the order is changed. Like their relative ordering, that is the odd positions, their relative ordering, and even position, their relative ordering are exactly the same in the last linked list. So 2 4 was there, here also 2 4 is there. 1 3 5 is there, here also 1 3 5 is there. So relative ordering of odd nodes and even nodes has not changed. So in such cases, there are a few more questions which have a similar thing, where relative ordering of some nodes is same in the output and other nodes is also same in the output. Why it is happening? Because we are only swapping these two. So this still remains the same, and similarly this also will remain the same. They'll not change. Repeat please, relative ordering. Sure, I'll do that. So what I'm saying is, if I am swapping like this, right? Let's assume there is a huge list also, and I'm swapping like two pairs. Then also this first will be before this third, and this will be before this fifth. Do you agree? Because they are being swapped in pairs. So 1 3 5 will always be in this order. It will not be that 3 will come before or 5 will come before 3, something like that. Similarly, when you look at this 2 4, again their ordering will also remain the same in the final output, because they are not being changed with each other, right? The even positions. So in those cases, I'm saying we can divide the list into two parts, one having the odd positions and one having the even positions. So what I can do is, I can simply say any nodes next will now point to this nodes next to next. That is, I will remove this, point it to 3. I will remove this, point it to 4. I will remove this, point it to 5, and remove this, point it to null. So what I have done is, I have split the list into two parts, one with the odd positions, not odd numbers, odd positions, which is 1 3 5 null and 2 4 null. Then I will interleave them in the opposite order. So what I'll do is, just like I separate it, now I'll combine, but take this guy first. So I will combine it like this, like remove this, add here, remove this, add here, remove this, add here, remove this, add here, and so on. So 2 first, then 1, then 4, then 3, then 5. Just like merging. If you remember, if you have done merge sort or some stuff like that. So I take one from the bottom one, then one from here, then one from here, then one from here, and so on. So splitting the string with odd indices, even indices separately, and then recombining it by taking the even ones first and then odd ones. Let's write a quick code for this, right? And see if we are able to get there. So let's say I have my head of the node. So let's first try to split it. So when we split it, we will have head 1 and head 2, right? So let's say I create head 1 as head. What will be my head 2? Can you point out? Look at this list. This will be my head 1. What should be my head 2? Yeah, heads next. Everyone agrees? Heads next. This will be my head 2. Right. Okay. Now what do I need to do? So while head is not null, ideally I need to just do head equal to heads next next. Sorry, heads next. What am I doing? Heads next needs to be heads next next. Right? That is, heads next needs to be heads next next. That is, remove this and add this. So basically, I'm saying any nodes next will be that node's next. Problem is, now that this has been changed, how to move ahead to this, right? I can't do that. So I need to have a temporary in the middle, which is heads next, and say I'll move to temporary now. So head becomes TMP now. So these two are for movement, because when I remove this and add this, I have no way of knowing 2. The only way to know 2 is by storing it in a temp and replacing it here. So this is for changing of pointers, and this is for that part. Yeah, you can write all those if things. I'll do that also in a moment. But yeah, let's come to when we need to stop. Okay. So when I am at 4, I will say 4's next is 4's next. This will work. But when I am at 5, I will say 5's next is 5's next. I can't do that. It will be a null pointer exception. So I need to stop at 4. How do I stop at 4? That means I need to stop when something's next is null, right? So till the point when something's next is not null, you continue. That means if the next is available, then continue. If the next is not available, then you stop. So this condition will slightly change. So see, don't in linked list, don't try to remember that, okay, we'll in this case, we'll write this condition. That will never work out. You need to look at a situation, and it's very easy to figure out from a test case that where do you need to stop, right? In general, unless it's something complicated. So now we have separated the two lists. What is next? We'll come to that. If you have to stop at 4, then head next. So heads next is null here, right? So what you can write is, if heads next becomes null, break. That is a possible solution. Or what I have written is, till its next is available. So when you reach 5, you need to actually break, like stop from there, right? So when its next is not available, then you stop. So it's just about if you want to stop at end or at the beginning. So I am stopping when I reach 5. If you want to stop when you are done with 4, you can write an if here, that if now heads next is null, then you stop. Yeah, what I was saying is, now we have got two lists that look like this, and we need to combine them. That is, head 2 first, then head 1, then this, and so on, right? So how do we do that? Again, I'm not writing termination right now. We'll see what the termination is. But I'll write the common case first. What do I need to do? If I have head 2 and head 1, I first need to point head 2's next here and head 1's next here. Break this, point it here, and then break this, point it here, and then move on to these two. They will make their own connections. Okay. Some people get confused how to know which connections to make in current loop and which in next. So in principle, what you do is, the nodes that you are currently on, their next you figure out, and then give out the baton to the next nodes in the line. So as an example here, I will make sure that pointers of 2 and pointers of 1 are in place. Then I'll pass on the baton to 3 and 4, that you figure out yourself. Okay. So as far as 2 is concerned, its next should go here. And as far as 1 is concerned, its next should go to 4. Okay. So which of the two connections do you think I should make first? 2 to 1 or 1 to 4? Again, it's a matter of choice, but still, if you can see a small benefit here, should I make 2 to 1 first or 1 to 4 first? Just a small thing, like you can figure it out later also. But when you want to make, as soon as you break this and make 2 to 1, can I see 4 is lost? Unless I store it in a temp, this 4 will be lost. As soon as I break this and make this 2 1, this 4 is lost. We can store it in temp, right? That's a possible thing. But generally, we try to reduce as much space as possible, right? So a better idea would be to make this first, right? So that 4 is not lost. and then move this. So what I'll do is I'll say head one's next will go to head two's next. Then head two's next goes to head one. So we have broken this, made this, then we have broken this, made this without any temp variable for now. Now the only thing is moving head one. I can move head two. Head two can be just moved by head two equal to head two's next. I can move it to 4. But moving head one is difficult because it's at 3. So how to do that? I need to store this in a temp. So node star temp equal to head one's next. Then I'll say head two goes to head two's next, and head one goes to temp. Okay. It might look like a little complicated, but just if you make those diagrams in copy, then it will be relatively simpler, right? What we are essentially doing is breaking this, moving it here. That's this. That head two's next is head one. Head one's next was head two's next previously. So 1 to 4 is made, 2 to 1 is made. But now, because 1 to 3 was broken, 3 is lost. And we need to move to 3. So that I have stored here so that I can directly move there. 4 is not lost. 4 can be found by this next. So that I have done here. So we needed only one temp to make these pointer manipulations. Okay, now when to stop, right? Let's say 3 and 4 also figure out their connections. So this 4 goes here. This 3 now points to null. And I'll say I'll go to null and 5, which is already bad. I can't go to null and 5. That does not make sense because it will break on, right? So ideally I can stop as soon as one of those become null. So either head 1 becomes null or head 2 becomes null. So if both of them are not null, then I need to continue, right? So 3, 4, after 3, 4, I go to 5 null. This is already bad. I can't change null's pointers. So I need to actually stop here. I can't go ahead, right? So I will stop as soon as I reach some place where one of it is null. Okay. Now let's look at different cases that are possible. So let's say there were 1, 3, 5 null, and there was 2, 4, 6 null. So in this case, when I change the pointers, both of them will be null. Can you see that? Like I basically head 1, head 2 would have been 1, 2. They would have figured out. They would have been 3, 4. They would have been 5, 6, and they would have figured out. Then both of them are null. Can you see that? Yes or no? When both of them are of equal length. In this case, I don't need to do anything. This is already sorted. If both of them are null, that means everything is already sorted. I just need to return the starting head 2, right? If they are not the same, like in this case, what is left? This 5 would be hanging around, right? One of the list would be hanging around. What do I need to do? I just need to add it at the end. So how do I do that? I will simply iterate and at the end add this 5. Just this will be left, right? This 5 which will be hanging around. So I'll just iterate and add it at the end. If you want to save some time, you can store the end and then directly link it. That's up to you. That's a small optimization. If you don't want to iterate again, every time in this loop, you also store in the end, and then that just directly link end with the 5. That's up to you, right? But 3 is pointed, yeah, exactly. So we'll not point it to null, but point it to 5. That is a change that we'll bring about. Okay. So iterate till you reach a node which is pointing to null, point it to 5 instead of null. Can't we use head 1's next is null? You can do all those changes. I'm just telling the most simplest thing that seems understandable, right? That's up to you. If you want to complicate it, that head 1's next is not null, there you stop. You can do that. That's up to you. But this could also be one possible way, right? I'll just let it happen. And then at the end, just plug in this 5 at the end, whichever is left, right? That's what we do in merge. Those of you have done merge sort, we one by one merge them till one of the array has extra elements left, and we chuck them at the end, right? Same I am doing here, just merge one by one, then whatever is left in one of the case, just put it at the end. Can ever the bottom list have more elements? No, right? It cannot. It cannot happen. Why? Because we are literally taking odd ones first, right? So yeah, so it can be either even or odd. If it's even, then they are equal. If it's odd, then first one has one more than the next one.